Hello everyone, welcome to NMIT course. I am Praveen Kumar, working as an assistant professor. In this lecture, we are going to be discuss about Newton forward interpolation. So the last session we discussed about three different points. If the point is located beginning of the table, we are going to be use forward differences, and using of the forward differences we are going to be evaluate. So if the point is located end of the table, just we practice how we are going to be construct the backward differences table. If the point is located middle of the table, then we are going to be use the central differences. We construct the central differences. Then today in this lecture we are going to be discuss about Newton forward interpolation. If the point is located beginning of the table, to evaluate that unknown value from the known values, we are going to be use the concept as Newton forward interpolation. So if you see the formula to find the value, if it is located beginning of the table, the formula is yp is equal to y naught plus p delta y naught plus p into p minus 1 by 2 factorial delta square y naught, so on. So where p is, we are going to be find using of the formula is x minus x naught by h. So where x is, for what values we are finding that unknown value, just we consider as x. Where x naught is the starting value of x series, where h is step size of x series. So as we know x and y series values, where x is the independent values, y is a dependent values or functional values you can say. So where x values we denoted with x naught, x1, x2, so on. Where y naught, y1, so these values we denoted for the function values. So difference between these x series values as denoted by x naught, like x1 minus x naught, x2 minus x1, so on, the nth value minus before value. So like these we are going to be used to find out the formula and h, x and x naught. So where if you see the problem how we are going to be applied to evaluate the unknown value. So one of the application we are going to be choose, and look at the question. Find the melting point of the alloy containing 54% of lead using appropriate interpolation formula, and given data is percentages of lead denoted by something p and temperature. So if you apply the temperature, so temperature whether the 205 degrees Celsius temperature and the percentage of lead, if it is 50%, then that melting point is 205 degrees Celsius. If 60% of lead, 225, and 70% of lead, 248 degrees Celsius is a melting point. 80% of lead, 274 degrees Celsius is a melting point. So from this, now what we require to find 54% of lead, and what will be the melting point or the temperature we require. If you see, this 54 is located around beginning of the table. So if the point is located around beginning of the table or starting of the table, so beginning of the table or starting of the table. So if it is beginning of the table and starting of the table, so we are going to be evaluate that particular point, we are going to be use forward differences concept. So first we construct the forward differences table. After constructing a forward differences table, we are going to be use Newton forward interpolation formula to evaluate that value. So for that, these are x values we have considered, and y values whatever the temperature it is given, just either you consider p or q or whatever, just generally we consider x and y. Now we need to be find the difference of these. So, difference of these two. First, we give the notations for this. This I am denoting y0, y1, y2, y3. So, difference of y1 minus y0. 225 minus 205 is 20. So, like difference between these two, 23. Difference between y3 minus y2, 26. So, these differences we denote as a forward table. So, in the last session we discussed the forward difference operator denoted by delta. So, therefore, this first order differences is delta. So, these differences we denoted by delta y0. So, in these two, first value, first variable, whatever is there, we give the notation for this. Now, difference of these two, y2 minus y1. So, as these two from these two values, this is obviously called the first value. So, delta y1. Difference of these two will be denoted by delta y2. This is called the first order differences. Now, we find the second order differences. So, second order differences is defined by differences of the first order differences. After getting the differences, again we need to find the difference. So, delta y1 minus delta y0. So, delta y1 minus delta y0. So, this is a second order. So, therefore, the notation is delta square y0. So, similar way, difference of these two will be denoted by delta square y1, right. So, similar way, we need to find the difference of these two, delta cube y0. So, this is what the third order difference is. So, based on these values, we need to extend this differences table. Let us assume 1, 2, 3, 4 values are there. So, number of values are 4. Obviously, our forward difference table will consist the third order, which means n minus 1th order we are going to be getting in the table. So, after constructing the table, so as we seen in the last slide, so this is a formula we are going to use. The formula will consist of y0, delta y0, delta square y0, delta cube y0. So, these values we are going to be substitute in the formula, simplify, we are going to be get that particular value. Look at the formula. So, Newton forward interpolation formula. So, y0 delta p delta y0 p into p minus 1 by 2 factorial delta square y0 p into p minus 1 p minus 2 by n factorial delta cube y0. So, since we see the table, we consist of the delta cube, so that we will write the formula up to delta cube y0. If the formula, let us assume the table will have delta power 4. So, therefore, will be extended to delta power 4. So, if you see the next extension is, so p into p minus 1, p minus 2. So, we will be extend one more term, p minus 3 by 4 factorial, this is 3 factorial, 4 factorial, delta power 4, y0, so on. So, that we are going to be substitute as we see from the table, y0 is 205, where p we need to be find. So, p as I said, the formula x minus x0 by h. X is, for what value we are trying to be find is, this is 54. So, that 54 is called x, minus x0. x0 is starting value of the series, x series is 50. So, 54 minus 50 divided by h. H is based on the provided data, as I said, difference between these two successive x values. So, 60 minus 50, 10. So, like this 10. So, 4 by 10 is 0.4 is the p value. So, that p value we are going to be substitute. So, delta y0, delta square y0, delta cube y0 from the table. So, as I said, y0, delta y0, delta square y0, delta cube y0, these we are going to be substitute in the table. So, simplify, you are going to be get the value as 212.64. So, this is what the value is, a melting point. So, melting point when 54% of lead. So, 54% of lead, 54% of lead, melting point is 212.64 degree Celsius. So, this is what the way we are going to be find the melting point of based on the percentages of lead. So this is what one of the application where we are going to be find the unknown value if it is located beginning of the table. So sometimes we maybe need to be find the polynomial. So what kind of the function which is involving in this, that kind of the polynomial or function we are going to be find. That is also one of the advantage and usage of this interpolation concept. Now we will see how we are going to be have that kind of the question. We will see now. So see the question, find the Newton's forward difference interpolating polynomial for the provided data. So some data is provided, x, f of x, data is 0, 1, 2, 3, x values, respective function values 1, 3, 7, 13. So look at the interpolating polynomial we are going to be find using of Newton forward differences or Newton forward interpolation formula. So first we need to be construct the forward difference table. So after constructing the forward difference table, that we are going to be substitute in the table, so that we are going to be get that particular result, right. So we construct the forward differences table, x, f of x, where x values 0, 1, 2, 3, function values 1, 3, 7, 13. So we need to be find the differences. First order differences, 3 minus 1, 2, 7 minus 3, 4, 7, 13 minus 7, 6. So second order differences. So 4 minus 2, 2. So difference is we are going to be construct as like in the previous sessions. What way we are finding that, just to learn, go back to the previous lecture and check how we are going to be constructing the table, you understand. So first we give the notations for this, y0, y1, y2, y3. So difference of these values we are going to be denoted by delta y0, delta y1, delta y2. So difference of these two, delta square y0, delta square y1. So third order difference is delta q y0. So obviously Newton forward consists, we are going to be considering of these starting values. So using of these starting values, we are going to be substituting the formula and we are going to be evaluate the polynomial. So as we see the formula, the previous slide, just I am repeating the same formula. So P naught, Yp is equal to Y naught P delta Y naught plus P into P minus 1 by 2 factorial delta square Y naught. So P into P minus 1 P minus 2 by 3 factorial delta q y naught. So these values we are going to be substituting that and we are going to be evaluate. So first we have to know what is P. P, the formula is x minus x naught by h. Where here we need to be find the polynomial. So x keep as it is minus x naught. X naught is starting value of x, that is called 0, 0. Where h is difference between the two successive values, 2 minus 1, 3 minus 2, something like. So therefore finally we are going to be get the p value is x. So substitute in the formula yp, or you can also call it as a polynomial y of x, where y naught. So y naught, see the y naught is the starting value of y, so that is called 1. So where p is x. So y naught delta square delta y naught delta square y naught delta cube y naught, we are going to be substitute using of the previous table. So delta y naught is 2 plus x into p is x, x into x minus 1 by 2 factorial delta square y naught is 2 plus x into x minus 1 x minus 2 by 3 factorial delta cube y naught is 0. So, 0 into something is 0. So, 0. So, just simplify this, we are going to be get the polynomial. If you simplify this, we are going to be get x square plus x plus 1. This is what the polynomial we are going to be get. So, the Newton forward, I have the two kind of the usages. One where we are going to be find the unknown value which lies or locating the beginning of the table. The other usage is finding the polynomial. Once you know the polynomial, you can substitute x is equal to 0. Will be get put x is equal to 0, will be get y value. So, where the data is provided up to only few values, but still we can able to find out even the value outside the table. That is the usage of this to finding the interpolating polynomial. So, in this lecture, just we discussed about the Newton forward interpolation formula, where in the next lecture we are going to be discuss about the Newton backward interpolation formula. Thank you so much.